Hey, hello everyone. We are going to start out the lecture like normal. If you want to if you want to go to your terminal, go to your repository, add your changes, commit them, and then fetch and check out the lecture. Then we can all get started on the same notebook. Another thing you could do if you want is if you go to, let me keep this on the screen as well for everyone so they can follow those steps. If you're having trouble with using GitHub, or rather the terminal, you can go to github.com, and if we go to Mark's user, I believe you can just click lecture 8 and just get this directly from the internet. But let's wait just a few minutes, maybe 3, reconvene at 1:04 so that everyone can get the notebook. And if you want to do it just through GitHub, be sure to click branches and then click lecture 8, because that's currently where the new lecture is. Okay, it seems like we have, 90% of respondents so far saying they were able to get the most recent branch. So something important, I have not merged the branch for today's lecture into the master yet. So you do have to check out this branch here, lecture/08, in order to get the updated lecture. So for the 90% of you saying that everything's good right now, make sure that your lecture 8 Python notebook looks like this, with the correct date and everything. That's probably the best way to check it. Make sure it's the 2020 version. And so let's actually relaunch that poll just to make sure. Everyone who said they were okay, if you could double check that you have the correct 2020 version. Seems like we have most people saying yes, so I'll take that as we're good. Yeah, okay, so if everyone, hopefully you got the 2020 version. If not, type in chat and I'll stop and we'll get this working again. Okay, so why don't we just begin? Today we'll be working with error handling, which is super important, and we'll set your code apart from the rest. It's going to be important, especially when you start building bigger programs, or when you build things to share, or you build programs to work with like someone who isn't really that good at programming. There's just a lot of different use cases. And we'll be also looking at files. So we'll just be looking at text files today, though a lot of the stuff that we're going to be talking about can work with image files and just any other kind of file you can think of. But this is just a lot of good introductory stuff, so you can understand some more advanced concepts later as well. Okay, so why don't we start with error handling? Okay, so we've all gotten these really annoying errors in our programs. I'm sure you've seen a ton of them, especially starting out. and they obviously always look something like this. You have kind of the name of the error is listed right here, a little bit jargony, there's different types. And then it gives you somewhat of a kind of an explanation about what the error is and what's wrong. And of course it tells you, you know, what line of your code and then exactly where the error occurred. Though sometimes this caret, at least when you're starting out, it doesn't seem like it's placed in the right place, but it is. So we can understand this decently well because we're the ones who are writing the code and we're developers. But to someone who's not so experienced that you would give your code to, they might not understand. And also, you might want to be able to run some code, let's say, if an error occurs in our program. So being able to anticipate those errors and do something is what error handling is all about. And we are actually able to do this using these things called try except blocks. And we're going to be using, before we get into learning about files more kind of rigorously, we'll just be using some basic file notation that I'm going to explain in just a second to demonstrate how you can use try and except blocks. So, okay, let's just talk about just kind of the basics of files. So opening a file in Python, like let's say a text file or a README or whatever, it's simple. It's just like this. You go f equals open, and then in the parentheses, you put in the file name here, and you store it inside of a variable. And then that variable has a bunch of built-in functions that can do a ton of things. So f.read, for example, or f.close. So f.read just kind of prints out your the contents of the file into the console so that we can obviously see what's inside of the text. And then f.close is special. So this is just something with Python. Every time you work with a file, you really should close it. Because if you don't, you might have like a memory leak in your program that just keeps hogging resources and actually will cause things to crash. So this is a critical part. And we'll look at that just in a second. Okay, so this is the kind of error that we'll work with today. So if I just simply try and open this file called tax documents for Beach Home, obviously I don't have one, or I'd be there right now, not freezing in New York City right now. So it's going to shoot me this error. So let's try and work with this in the using a try and except block. So the basic anatomy of a try and except block is in the try section, we put in code we think is going to break. And then in the except section, that is only going to run if something does break. So it makes it so that if your code works perfectly fine, the special code you write in except will not run, but if something goes wrong, except will actually run. So this is what kind of it looks like. I have pass here. You might have seen this in the iteration portion of the lecture series, but pass is just kind of a placeholder that lets our code run and not produce errors if we don't want to actually put in anything. It's just basically a placeholder. So I mean, let's say I put like a equals 1. A equals 1. This code's going to run fine. You're just assigning 1 to a. But if I don't put pass and I try and run this, it's going to say something's wrong. So obviously, you have to have some kind of code in there or Python's just going to break. So that's where pass comes in. So if you see that, that's what that means. Okay, so let's just first try to fill in our try except blocks. So we want to try and do something when we get an error like this file not found error. Well, let's put into our except block just a print statement that's a little bit more clear. So you can see here that instead of printing that big kind of error, it prints just what we put inside of the except section of this block. It just says, sorry, test file was not found in the directory of this file. So when you're trying to open something, it only looks in the current directory of, let's say, this Python notebook. So that's why I wrote it like this. But yeah, so this is just really basic stuff for try and except blocks. So now that we but this kind of replaces that default error that we saw before. So that might not be the best because maybe we also want to see that default error message. So we can actually just change up this except section of the try and except block so that we can see not only what we want to write, but also something new. So I have down here what that might look like. So I do the same thing, I go try, and then I put in the code that I know is gonna fail because we have no test file currently in the directory. And then in the except portion of this block, I say accept exception as E. And the first print statement is normal. It's just sorry, but the test file was not found. And then I put a couple blank print statements so that we have some lines. And then I say Python default error message, print a line of these asterisks, and then I print E. So when I want to capture what that error message would have been if I didn't have this try except block, all I do is I go accept exception as E, and then that E is going to have that error message. And you can see here, this is the same. So this is the classic error message we get: the file not found, error 2, no such file or directory, test file.txt. If we go up to see, we have one of those before, it's the same thing here: file not found, error number 2, no such file or directory, test file.txt. So this is a really good way to add something into just the default error message, especially if you there's some kind of thing might break, and you want to include some context to some user that might be using your code. So let's just keep going on. Okay, so this up here captures kind of any exception that is under the sun, right? But we can also capture specific errors. So let's talk a little about how to do that. First, we have to understand what different specific errors are. So we've been looking at file not found error a lot because, I mean, that's what happens when there's just not the file that you're trying to open. But there are a couple other types. These two you probably have interacted with being beginners, because, so this one, for example, syntax error, if you look at this code block here, you might notice that there's a colon missing. So that's, incorrect Python syntax. And because of that, you'll get a syntax error if you run something like this. And lo and behold, this is what it looks like if you try and do that. So syntax error invalid syntax. It's pretty simple. Points up to where you should have the colon. There's also something called an indentation error that you might have gotten. So if you look at this code block here, the if and the print statement are on the same indentation level. But obviously, when we make if blocks or try blocks or all these different blocks we've learned about, you have to have the print indented. So this obviously makes your indentation error right there. And I think Elsie is asking in the chat if it's better to put several print statements or just the /n. I don't know if one's better. Let's get a discussion in the comments. I just usually do print because it's a little bit more, I guess, readable for me. But yeah, Emily agrees with me. Okay, so let's continue on. Sorry about that. Okay, so yeah, so let's build a try and except block now that has multiple parts, multiple except sections. So this is one I built down here. So we're trying to do that same thing, open that file that we know doesn't exist right now. And instead of having except exception, I have except file not found error. Now remember, file not found error was that piece of text that was just hanging in that error message right here, file not found error. So this is the special name of that error. So let's go back down, back in that new block. That's what I put, and I can still save it as E like normal. And if I run this, you can see that nothing changed from before. So it still says sorry, but your file was not found, and then I print the default error message right here. And that's great that nothing has changed, because if we do except exception, this will take any exception. But I mean, we know that the exact error is the file not found, so it works perfectly. So that brings up the fact that we can have multiple except sections as well. So I can have some very specific except sections up top, and then have more general ones on the bottom. And the reason I want to do this is because when Python tries to figure out which except to actually run, it goes from top to bottom. So if I had except exception as the first except section, then none of the specific ones later down would actually ever be triggered. So always go from most specific to least specific. So found not found to exception, for example. And you can see here, there's two different print statements for either error. So if we run this, we're gonna get sorry, but test file.txt was not found, which is just what we were doing beforehand. We were trying to trigger that if there was a file not found error. But let's say we comment that out and we do something like variable equals variable2. So this won't work because there is no variable named var nor var2. So if we print this again, we actually get a different message this time. So we get sorry, something went wrong, and you can see that's exactly the print statement I made for just any other exception. So except exception as E, just any of the other ones besides file not found. Cool. Hopefully that makes a decent amount of sense. And that really is try and accept blocks in their most basic form. Okay. So we're going to talk about try except else. So there's a couple different additions we can add on to try and accept. And the first one we'll talk about is else. So else is just another section we can add on, and it is only executed if no error occurs. What we need to actually do, so previous examples, we weren't able to actually open that test file. And that's how we actually demonstrated, capturing all of these and printing different statements. So if we want to test out the else section, we obviously need to have no error occurring. So this piece of code right here, you don't have to understand it at this moment. Later after the lecture, it might be good to go and check out this block because you should be able to understand it completely. But if we run it, it's gonna actually make a test file. The one that we've been trying to open for the whole lecture, but it'll create a test file in the same directory as your notebook. And we'll be using this for these try except else examples. So here I have that exact same block that we were working with just previously. So we're trying to open this file, and I have here, I've separated out into a variable just so that when I get that file not found error, it will print out the actual file name, and you'll see why in a minute. Okay, so in the file name, I'm just putting the exact same thing that we've been doing before. And if I run it this time, it actually prints to the console, hi, this is the contents of your text file. So that was the contents that I actually put in that file when we created it above. And you can see this only happened because there was no error in the try section. So the block defaulted to running the code in else. So f.read just prints out whatever was opened in that file name. So you can see that it says print f.read, and that's what produced this message down here. Now, if we change the file name up here to file that doesn't exist, this file doesn't exist. We never made it in the section above. So now it's gonna default to this block here that was that file not found error. And you can see that it did. So because this file doesn't exist, it creates this error and then saves it as E, prints that out as the default message down here. And you can see just because I separated the file name into that separate kind of variable, it prints a really pretty, sorry, but your file that doesn't exist.txt was not found. Cool. Okay. Let's keep going down. Okay, so another sometimes forgot about kind of section you can add to try and accept is finally. So finally executes no matter what. And it's probably the lesser used of the try excepts. There's a couple uses I can think of. Like, we want our programs to kind of end gracefully and not kind of shoot at us in the face that something's wrong. So you could have like a nice little goodbye phrase, like, program's done, whatever. And remember, when working with files, I kept saying that we need to close files. So this is actually a good way to close out your files when you're done with them. We'll find out the actual truly proper way in a minute, but that's also an example of something that might be good for finally. We haven't talked about them, but different database libraries and things like that finally might be good for closing databases. Yeah, those are just a couple I can think about. So here's an example, the same as above. We're opening that test file, and then we are, the exceptions won't happen, obviously, because this is the test file we actually have in our directory. And what it should do is it should execute else, because it was able to properly open test file.txt. And then it should trigger this finally, which is going to close it, print an empty line, and then say, thanks for using our program. So let's run that. You can see that's exactly what happens. So it prints the contents, closes, and then it prints out this just nice kind of goodbye string. Yeah, so that is try and accept blocks. So you can really mix and match. I can see Lily sent out actually a list of the different exceptions. So you can, if you think you're going to run into one of those, you can obviously put them into an accept section, but you can also just kind of do trial and error. So when you're getting errors that are like something's wrong in your code, just pay attention to what kind of error it is, and you'll be kind of surprised as you continue on with the writing code how fast you'll memorize a lot of them, because they pop up over and over. So yeah, those are kind of two different ways that you can figure out different specific exceptions, because we want to limit the amount of blanket accept exception that we actually write, because you always want to know exactly what's happening in your code. So try and be as specific as possible and use specific exceptions like the found not found before. But yeah, you can mix and match different accept sections. Finally, else. You don't need to have finally or else unless you really want to, but yeah, just play with those and see what you can get. Okay, so we're also going to just finish off this section of the lecture with raise. So raise actually allows you yourself to initiate errors, to just kind of instantiate errors almost. So this becomes really important if you start writing your own like Python extensions and libraries and things, because you can actually create custom errors. So like how we had found not found or indentation or syntax errors and things like that, you can create your own errors that are unique to your library. With their own kind of prints to the console and things like that. So this is really where raise becomes super important. But even for kind of specific or for simple examples, it can also be pretty useful. So I hope no one has the word password as a password in any of their online accounts, but that's the kind of the basis of what we're gonna do right now. So it seems like this is actually right now markup and not code. So that's just my error when I uploaded it. So if you want to make this code, if you just click the cell and then press Y, it'll transfer it to code, so we can actually run this. Or of course, you can just make a new cell if you want. Okay, so so this is the example. You should be able to understand this from learning about input before. But basically, what we're going to do here is we're going to try this code where I ask users for input, save it a password. And if someone put password as their input, it's going to raise just a general exception. Now, if I was making some kind of custom library, I might have, my really, really bad password error here and raise that, but we're just going to be simple and talk about this really simply. So we're just raising the general exception. And then I have my accept block, accept exception, and then print, please input a password other than password. And then if they do anything besides put in password, it's just going to print that it's successfully saved. So if we run this, let's just put in password and say enter. Where is it? You can see that it says please input a password other than password because I inputted password there. And then if I print anything else, so let's just do ASDF, for example. It says your password has been successfully saved. So that's basically raise. It's done a lot when you have these if statements within your try, because you're trying to make sure that something is going right. And you can raise things wherever you really want in the code. you don't have to, they're not only for tries, but just is just a thing to know. Okay. So that is basically everything we want to cover today on try and accept. And we're going to spend the rest of the time talking about files more in depth. So we kind of briefly touched on them just because they're pretty useful when it comes to errors, because they print something out basically if they're opened correctly without an error. But we're going to talk about them more, much more in depth. So this is, I think, in the lecture, kind of the first foray into reading things into Python programmatically. So by that, I mean, you're not like copy and pasting something into a cell. It's like, if you copy a large list, you can say like the list equals to, I can't spell today. And then you can literally paste large lists into Python very frequently, especially if they're separated properly in plain text. But that's not good. You want to load things in programmatically. So we'll be talking about, I think we have this scheduled, Pandas, which is kind of like it's like a spreadsheet library in Python. It's a third-party library. That's the main way we'll be really importing data sets throughout, I guess, hopefully most of our careers. It just keeps on being updated and everything. But let's say you're not working with a spreadsheet type of data. Let's say you're working with like prose. So, there's those machine learning algorithms that like predict, or like they can write books themselves, for example. I mean, those will have to be reading in a lot of text. So this is an example of kind of the stuff we'll be dealing with today. Opening text files. You can make your own kind of Harry Potter fanfic generator by reading in kind of public paragraphs and then running on an algorithm on that. Another thing is like error logging. So how we did accept exception as E. There'll be an example a little bit later where we take that E, we make it a string, and then we can actually save it to a file. So this might also be important for that. But there's a lot of applications, and this is also just kind of important to know generally going forward. So the most basic thing you can do, and it was what we were doing in the try and accept part of this lecture, was simply opening a file, printing all of its contents, and then closing it. Closing is important. So we're going to do this again, just a little bit more methodically. And we'll be using for this part of the lecture something called canada.txt. It's just a list of all the provinces and territories. And this should be in the directory of your notebook if you properly did the git and everything. Okay, so the three basic kind of commands that are down here, I have them explained in this thing, but let's just go through them verbally. So the first thing that we do is we use that open command. And the first argument here is going to be that name of your file in the same directory. So this can also be a path, but just for our case, we're just dealing with that file in the directory. So we're just going to go canada.txt. The next thing it takes is the mode. So this mode kind of gives you read or write privileges and things like that. We're going to stick with mode R. So this is just a string R that lets us only read the file contents for now, but we'll talk about write, append, and read write later. So this is how we open a file. It saves it as a variable f, and then we can use a bunch of built-in functions in f to then do what we want to do. So if we print f.read, and this is a function, so you do have to have the parentheses and have them closed with no arguments, at least right now, for it to work. This will print out the contents, and then as always, we need to close the file. So we do f.close and then parentheses. So we run this. We can see that we get a list of all of the provinces and territories right here. Perfect. So that's the basic stuff. And I introduce it because there needs to be comparison to the way that we actually do this usually. So we usually use with. Oh, okay, so Toby sent me a message that in fact it's called a context manager. So we're gonna put that there, which makes a lot more sense. But okay, I probably have it written here as content manager, but it is in fact a context manager, and you'll see why it's a context manager in a second. Okay, so instead of doing this kind of manual open, read, close, what really would be great is if we had a system where we could just like open it and then it would automatically close when we're done. So that's what context managers do. So context managers, in one of them in Python, it's called with. So it's a new kind of block. So in this context manager with, what we do is we say with open, same stuff as before, the file name, and then the mode. So this mode actually should have, so this of course needs to be a string. It wasn't just written in there, so I just added it. So open, you kind of just rearranging things before. So instead of saying f equals to open Canada text and R, we're putting with open as f, and then the colon, because it's a block, and then doing all the different kind of built-in functions and other things inside that block. And then it will, if we structure our code this way, it'll automatically close the file when we're done with it. So let's just look down. So this is a proper use of with. We say with open Canada R as f print. So if we run this, we'll see we get our list. But what's important to know is that when we're using with blocks, everything that needs f to be opened, like reading stuff in f or writing stuff in f, etc., needs to be done inside the block. So if we put the print statement, print f.read, outside of that with, it's actually going to produce an error. So we get this value error IO operation on closed file. So it's just very important when working with these context managers that we need to put everything with f inside of the block and not outside. So this is pretty simple right now, but it might catch you, may just be confusing later. So if you get this kind of error, just wanted to kind of explicitly show you like what might be happening. Okay, so previously we were just reading everything in the file, right? But we might want to do something a little bit more kind of nuanced. Like maybe we only want to read in a couple lines of this file. Like we know that this is kind of a small file and we know the structure of the file. We can just glance at it. It's alphabetical. It's, you know, just a few entries. But if we are reading in something that we don't know the size of, which is very frequent, or yeah, we want to read it kind of little by little, not just all at once. And this is important. I mean, even if we work with something small, maybe like this list here, this might be important just because consistency. This way, it never really breaks. Yeah, you can also like run into issues too if you're trying to open too big of a file, because it might be too big for memory, but that's only with the really big files. But anyway, yeah, so here's a couple of ways of doing that, reading only portions of a file and not the whole thing right away. So something that's really good with lists is Readline. So this might be a little bit confusing because I don't think we've really seen it before, how Readline works. But to use it, we just kind of do the same exact thing that we did previously. We use our context manager with to say with open Canada R as F, and then we print Readline. So this will give you that first line. But what about all the other lines, right? Well, you have to repeatedly call this function to keep going line by line down. So if I, instead in this block, I have just that same exact command, but once more, and if I run this, you can see that it actually prints out that next entry. And if I do it again, it'll print out the third entry. So this is, I don't know if we're covering it specifically in this lecture, but if you want to read up on it, it's all iterators and those kinds of objects is what, and next methods, I think, is what is kind of the basis of this code. But essentially all you need to know is that if you want to keep reading further down the list with Readline, you're going to have to keep printing the different statements. And if in your head you were thinking, well, instead of manually writing all these Readline statements, I can just make a loop because we learned about those previously. This is actually a great application of that. So here is what that would look like. So here's a way that you can use a while loop to read out the whole contents of candidate.txt list, just line by line. So to do this while loop, what we're essentially going to create is an infinite loop that will break once we can't read anything more of the file. So if we keep on reading this, printing this over and over and over and over and over, it's going to print, it's going to keep executing that line. Like nothing, there'll be nothing that will error if we keep calling readline. But once we run out of things to read, it's going to start to give us empty strings. So basically, if we make a while loop that first reads the first line, okay, f.readline, saves that to contents, and then we create a loop that checks to make sure with every kind of iteration of that loop, tries to make sure that contents is not an empty string, or in other words, the length of that string is more than 0. Then it will keep going. So this is like a kind of an infinite loop with a break condition. And if we print it out, you can see that we get everything. So essentially what's happening in this loop, like I said before, is that we get that first contents, and then we start a loop, it'll print it, and then we'll overwrite that contents variable to get the next line, and it'll keep going over and over and over. And then once it reaches UConn, and it prints UConn, then it tries to pull that next line, but because there is no next line, it gets an empty string. And then when it checks the length of that, it is 0. So this fails and it stops that loop. So this is one way that you can print out everything little by little. But there's also a simpler way. So if we open that file, just like before as f, there's something built into f where if we try and create a for loop, it will actually iterate over the different lines. So if we just go for line in f, or line, this line can be any variable name you want, but line is classic. And then we print that out. It's actually going to print out everything like before. So this is a really simple way of doing it. And this above might seem a little bit complicated, but there will be certain circumstances that using these infinite while loops with kind of this break condition is important. So that's why I kind of described it up here. But if you just want to go line by line, this is probably the simplest, most readable way to do this. Okay, and as you can see, there is an empty line between each of these, and you might not want that. So we're gonna introduce something here called end. So in your print statements, if you put a comma and say end equals, and you can actually pass it something to print at the end of each of your print statements. So this is actually is kind of invisible to us usually. And it usually prints out an empty line. So it does that /n kind of thing. And that's why there's an empty line between each of our entries here. That's also why if you just do a, if you do an empty print statement, you get an extra line at the console. And that's because you are printing out that empty line. But if we go end equals to empty string here and then play that, you can see the lines go away. So this is just important if you have problems with, if you have kind of larger lists, maybe you want them to stay in your window, or just there's a lot of other reasons, but we'll see that in a minute. Okay, so reading, so instead of reading by lines, let's say, you're looking at a paragraph, or maybe you're even working within a list, but you want to read instead of line by line, you want to read character by character. So we're going to reuse f.read before. But this time we're going to pass it this variable called size. So the size argument's new, and what it's going to do is it's going to read that amount of characters instead of reading everything at once. So let's see how that works. So kind of we start with the same thing as before with our context manager with. We do with open candidate.txt in the read format. And I'm going to create a variable here called size to read. have that as, we're going to do 50 characters for now. Let's actually make it small. Let's make it five characters. This can be anything you want right now. And we're gonna make that variable contents, and it's going to be equal to f.read, and then that size to read. So this is going to be similar to the readline that we looked at before, where we're going to create a while loop, and we are going to iterate throughout the whole file, reading just 5 characters at a time. So this is going to get from the very top of the file 5 characters in, and then we're going to have this while loop that's going to be printing out every other 5 characters until the end of the file. So let's play this. And you can see that because our print statement here doesn't have end equal to empty string, it kept inserting empty strings every time we got 5 characters. So let's do end empty string, play this again, and you can see we get our exact same list as before. But let's actually let's put end and put an asterisk in there to actually make it explicitly clear exactly where every 5 characters looks like in our document. So if I run this, you can see that every 5 characters, it actually printed an asterisk, because that's how it's this kind of while loop is slowly but surely printing out everything to the console. It's first getting Albert, and then so that's in this initial contents line, and then it's initiating the loop. It's printing it out, so it prints that out, that Albert. Then it gets the next set, so it gets from this T to this R. And then since that has a length greater than 0, it is in fact 5. It prints that out again, and then it's up until this very end where it can't get any more contents, and then it is the length is 0, so it breaks out of this loop. Okay, so let's continue on. Okay, I apparently had a different different block to demonstrate that, but I just kind of merged those together. Okay. So we covered f.readline, singular, and f.read with a size argument. Another thing that we can do if we have something that is a list is f.readlines. So I recommend that people go to this plaintextlist.com website. It has a lot of lists that are in plain text that you can copy and paste, or just kind of save them in your text editor. Why does this website exist? I don't know. But that's actually where I got the list for today's lecture. But let's say you get a list from that website, and you want to read all of it in at once, but you want to read it into a list. We could create an iterator, or sorry, we could create a for loop that reads one by one and then kind of appends onto the end of a list. But f.readlines just does the work for us. So here's an example. So we open it like normal, and I'm actually gonna call this this function and then save its output to Canada list, CA list down here, and then that will allow me actually to print it outside of the context manager. But let's print that, and you can see that from the square brackets that we learned about previously, this is a list. And it includes this this character, that's that new line character, because inside of our text document, if you look at it, you can see that there's a return between every line. So that's why that's in there. But you can see that we have a list with this, so you can see from the square brackets, where every single element is just one of the territories and or provinces. Okay. So that is a quick introduction to just reading. But obviously sometimes we might want to write things to the file, or edit things to file. So that's where some other modes that are just not that R mode that we've been using for now on or previously. Okay, so we're going to look at 2 modes. There's a bunch of modes. If you want to read up on more of them, you should go to the documentation, but we'll just look at W and R+. So when I say kind of write to file, I don't know what kind of pops up in your mind, but in Python terms, it can actually mean a few things. So write to file can mean, create a new file. It can mean overwrite existing files or contents, so like editing things, or appending, so where you don't even kind of look in what is currently in a file, but you just add stuff to the end. So it can do all of those, and we can at least make new files and edit files using W and then R+ mode. And then we'll talk about append at the very end. So the W write mode, this creates a new file. So if we do an open, a file name, and then W mode, if that file doesn't exist, anything that we write to that file is going to be put into a new file. If it does exist, it's going to completely overwrite the previous file without warning. So this is kind of a worry. You want to make sure that when you use it, you're not going to be overwriting things, or possibly build a check in your program beforehand to make sure nothing is existing with that file name. And then, other is this mode R+. Okay, so this lets you basically edit existing files, and we'll see examples of that later. That's its main use. But so the thing we're going to do right now is we are going to create that log file I was talking about before, where we have an error and then we save it to a file that's in the directory of this notebook using W. So let's see how that's done. Okay, so we are going to try to open a file that doesn't exist. So this sort of f equals, I say broken code equals open, doesn't exist.txt. This is going to break because we don't have that file in the directory, but we're going to try and open that. And lo and behold, what's going to happen is, it's going to trigger this except section, and it's going to save that exception as E. And then we're going to cast that to a string, or we're just going to make that E into a string to then be written into file. And I named this error message. Okay, so here is the actual new stuff with the W mode. So if I use in my context manager, I say open new file.txt, W as F. All I have to do is do this new command f.write, and then this is the string. So this is any string I want to save, but in our specific case, I want it to be error message, the error message of the thing that broke before. And then that saves it. That's the command that saves everything. But I also then down here, I'm opening it up in R mode, right, read mode, and I'm going to read it out and print it to the console. Okay, so let's see how this goes. Cool. So you can see the console here says error number 2, no such file or directory, doesn't exist.txt. So this is the same kind of annoying error number 2 we were getting previously in the lecture when we were working with the try except blocks. But actually in this case, it's written to file. So if you want to check it out, I mean, open your Explorer, and you can see that you have this new file.txt. You can actually open it. You can see that it's right there. Created programmatically via Python today. Okay, so let's go back to the notebook. Okay, so that's W at its most basic. But what about R+? Okay, so let's say that for some reason we want to change inside of that text file error number 2 to error number 3. We can edit text files in our system by using R+. And you'll see in a moment, but when we edit files, we're basically gonna, if we just kind of edit it as is, it's gonna start from the top and it's gonna insert text. So inserting is like if you've ever accidentally or for some reason clicked insert on Microsoft Word, and when you started typing, things didn't move out of the way like it did right here, but it starts to overwrite anything that exists in its way. This is also, the same thing as insert mode in Vim if you've used Vim before, and I think we have in this course. So okay, what we're going to do here is I'm going to just print original contents, and then right here, use the context manager in R mode to open new file, which is this file that we made up here with the error message. We're going to print it out, and then we're going to use R+ mode to edit. So f.write is going to default to start editing at the very top of the file, and it's going to write in error number 3. And then it's going to print out new content. So let's press go. So you can see that original contents, error number 2, Mrs. File directory doesn't exist.tt. That's what originally was there. And then this here command ran, which went to the top of that text file, and then instead overridden using that insert kind of method, this new string error number 3, and you can see that that's showing up right here. So it says error number 3, no such file directory doesn't exist.txt. If we go to the Explorer, click that new file, you can see that it is in fact changed in your hard drive. So you did actually change something in your directory, which is pretty cool. Okay. And so this f.write works like the readline we did before. Like if you want to continue moving throughout the file, you got to keep on calling it. So we could call it again and then play this. And you can see that just like readline, after I call it once, if I call it again, it starts right after that and then starts overwriting again. So original contents we had was error number 3, which we changed previously, no such file as directory. But if I run this twice, it's first going to start at the top, write in error number 3. That's identical, right? So even though it's overwritten, you don't see a change. But then because I called it again, it started right after that and then printed out error number 3 there. So this works just very similarly to what we saw a second ago. Okay. So that might make you ask, well, what if I don't want to just edit the thing at the top? And what if I want to edit something here and not touch what's in the middle? Well, that's where we use the seek built-in function. So what we can do is we can use seek, and then seek takes in a location argument. So if I say seek, let's say 10 in our case, what it's going to do, 1, 0, is it's going to look for it's going to go to the 10th character, wherever that is, and it's going to start right there. And it's going to then do anything we say it will do. So here I'm going to tell it to do f.write, error number 3 again. And it's going to go to the 10th character and then start inserting that in there. So that you can see this is a very similar kind of text to before. I just put in this seek function. So let's run that. And you can see, so I guess this character right here was in fact the 10th character. So it started there. So this E right here, that's the 10th character. So seek 10 brought it right to that E. And then I did f.write, and it started to write error number 3 right there. So you can see that it inserted error number 3 right where I told it to at the 10th character. Okay, so that is this R+ kind of editing mode with fseek. Okay, so why don't we then now learn about overwriting files? So using W mode can be a little dangerous because it overwrites things kind of without warning. But yeah, if we don't want to edit something, let's say we just want to create it new, we could use this write. So I have a similar kind of block before, it's original contents. And we're going to read out the original contents. It's going to be this mess of a string. And then I'm going to do that kind of same open command, open new file text, but I'm going to open it in W mode. And then if I do this write statement here, it's not going to overwrite this portion, but it's going to rewrite the whole file. So let's press go and see what happens. So you can see that's exactly what it did. It prints original contents. It opens the file as it were, which is this kind of mangle of text we were playing with in the previous blocks. And then if we open the file again in W and then do another fwrite, because it's in W mode, not R+ mode, it will just simply overwrite the contents. So now the contents is just simply error number 3. So if we go to the Explorer, we go new file, we can see that this now is just simply error number 3. Everything else is not there because that's what we said here, because we're in W mode. Okay, and yeah, so I don't think I have it. Yeah, I don't think I have it is explicitly later down the line. But you know, if this is so I'm gonna, so if I said this previously, but I don't have like a demonstration of it. So I thought I'd just quickly put a demonstration in here. But let's say, let's just make ASDF because I have too many news in my file names. So if I try and open in W mode a file name that doesn't exist, so you can see there is no asdf.txt in this directory, it will actually create that file. So this is a newly created file. So if you do this, and let's open up that new file I made, asdf.txt here. So what I'm doing right now is I'm just simply demonstrating the fact that not only does W overwrite, but you know, if the file doesn't exist that you're trying to open in this open command, it will create the file just out of thin air. So let's run that. So what this did is it I tried to open this asdf.txt in W mode, and I did an fwrite because that file didn't exist. Created it right here. And then I opened the file up and did an f.read to read the whole contents, and I printed that to the terminal, so you can see there, it works perfectly as expected. Okay, so the last mode we'll talk about is A. It's the append mode. So let's say, I don't know, you're like running a really long kind of program, like, you know, maybe on your computer locally, or on the cluster or something like that, and you know that there are going to be certain kind of checkpoints throughout this kind of computational experiment you're running that you want to save to a file, right? You want to just continually append a file. You want to use something like A. So A mode will append to the very end of a file whatever you pass it in that fwrite. So this is super useful for, like I said before, kind of logging kind of things during experiments and yeah, or just appending things to lists, really. I can't think of any more concrete examples, but that's mainly what I have used this A mode for. So this is the same example before. We have that new file.txt. So that contains now, because we overwritten it, just this text error number 3. And now let's append another error number 3 onto it. So we're going to open that in A mode, fwrite, error number 3, and then we're going to read out the contents. So let's press go. It's blocking me. There we go. So what this exactly did is it just read the contents, which was error number 3. And then since I opened it in A and did an fwrite, you got them back to back. And then I just read it out. So you can see how if I do this, it is adding it without a new line. So if you want a new line, you want to do that /n that we've been using before. So if I print this now, you'll see that it read in what we had appended before, this error number 3, that new file, because I had physically written it to file. That's what we have now. And then now I added this kind of new line error number 3 and it added one here. So if we keep pressing go on this, it'll just keep adding error number 3 onto that, appending it onto the file. And I bring up this new line thing because I said that this is useful for like, logging events during a long kind of experiment on a cluster or what have you, whatever you're doing. So this is something you'll probably actually need to use when you're appending, as just to keep things clean, always appending stuff onto the next line. Yeah, I thought that too. That's probably why it's highlighting. Mark's just saying that we usually put the new line at the end of it. Yeah, it doesn't seem to break it, but I guess if that is the in fact best way to do it. Okay. Yeah, so with all of these different tools under our belt now, we can actually copy a file. So this is the last example of the lecture. Using everything we know, how do you copy a file? So obviously, if you want to copy something, what you need to do is you have to open an existing file and open it in R mode because you want to read the contents of one file. Then the next thing we're going to do is open another file that is in W mode because we want to create something new. And then inside of that kind of nested with loop, what we're going to be, or with block, we're going to iterate over all the lines of that original file and just F-write them into that new file. So that's what I have right here. So it is kind of the first instance in the lecture of a with within a with, but we are opening up canada.txt in R mode, and then we're going to open up another file, canadacopy.txt, into W mode, and we're going to this is something I might have not touched before, but it's probably obvious to most of you. This doesn't need to be F. This can be any variable name we want, simply a variable name. So down here, when I made this new context manager for the new file we want to write to, I named it new F. Okay. So within this nested with block, I have a for loop using that kind of simplified line iteration that we saw previously. So for line in F. So this is going to have for every single loop, it's going to just have the next line, until the line there's no more lines. And I'm just doing new f.write line. So I run this, we get a new file right here. And this next block here is going to open up canadacopy.txt into R mode and then read that out. You can see, there it is. And if we physically, or rather manually, open the file, you can see there we go, canadacopy.txt. And it's the same thing as just the normal canada.txt we were working with. So yeah, that is really it for today's lecture. I put down here just another built-in function that might be interesting. If you do f.tell, it's going to tell you where you are in your current file. So obviously, doing these writes or read with a chunk size and things like that can get confusing exactly where you are. So this f.tell might be useful in your programs. But yeah, so today we kind of just work through error handling, the try and except blocks, try and except to catch specific errors, why it's better to do except sections with specific errors instead of kind of general ones, and then else it finally. Else only runs if nothing went wrong, and then finally runs no matter what. And also raise. And then we also talked about kind of opening and closing files, how to do that properly with the context manager, reading files of all sizes. So you want to probably read them little by little to make sure you don't do anything like overload your computer and not do anything wrong. And then writing files, which includes making new ones, overwriting, appending, and editing contents rather. And then also copying files. So we can do this with two with blocks that are kind of nested in each other, and then a for loop. But yeah, that's just everything for today. Thank you all so much.